Hi, my name is Sunil Grover, Principal Solutions Architect for SAS, and today I'll be sharing a demonstration using visual statistics to showcase logistic regression analysis for a variety of predictive marketing applications. With that said, let's jump into it. In this demonstration, we'll be highlighting visual statistics in the context of logistic regression analysis for the purposes of understanding drivers of website visitors and what causes them to convert or not convert. Over here in the right menu, you'll notice that I've assigned an attribute that represents a conversion indicator if a visitor did or did not meet that criteria on their visitation experience. I now want to add additional attributes in the form of classification and continuous effects to help understand and isolate those signals unique to conversion behavior. First and foremost, as I come over here to my left menu where all my attributes exist, I want to search for attributes that represent visitor interest when they came to the site. What types of contextual areas of the site experience were they checking out? I'm going to select those attributes and fold them into the analysis, and they'll be assigned as classification effects. The next attribute, let's grab something that's popular in the web analytic world in the form of visitor engagement, and let's drop that into the analysis. Next, I want to highlight a very powerful feature in visual statistics. What I'll be pointing you to is how to assign attributes to this group by role. And what that means is, rather than building one regression model on the entire audience, I now want to build multiple regression models based on the attribute that I fulfill in this group by role. I'm going to select a variable by the name of traffic source, which represents which marketing channel did that visitor come from. As I select it and I assign it to the group by role, Visual Statistics is very efficiently going to create 7 unique regression models for each particular channel. And we can see that over here in our fit summary plot. Let's expand that. So what's happening here? We've built a model for social media visitors, for those that originated from organic search, from blogs, from online display, and etc. And if I want to explore what variables are uniquely important to each of those particular channels, I can come over here, I can select a variable. Let's select something like those who are interested in business analytics, and I can see by the horizontal green lines that those who originate from blogs, those who came from paid search, and those who came directly to our site, this particular contextual interest area is important to them. But if we select a different attribute, let's say we're interested in visitor interest in visual analytics, the variable importance plot will update and provide clear indication as to which unique traffic channels showcase interest in that particular content. Let's go ahead and minimize this plot. And let's take a look at the assessment plot. For an analyst that wants to understand if he or she is building a good model, Visual Statistics provides 3 visualizations in the context of assessment. First, a lift chart. Second, ROC plot. And third, a misclassification rate plot. With respect to outlier analysis, we can actually investigate the residuals, and if we find certain observations are deviating outside of our level of satisfaction, we can actually select those offensive observations and make the decision if we would like to exclude them from the analysis or not. With that said, there are other property settings to highlight. If you would like to deal with imputing missing values, if you would like to use variable selection, and other common techniques to further optimize your regression model, you will see a wealth of options over here in the property settings. Now, how would we take action on this model if we had come to the conclusion that we were happy with the analysis? There are a number of options to take advantage of. First and foremost, we could export the score code. By clicking here, Visual Statistics will auto-generate that score code, and we could now bake this code into a marketing workflow so that we could operationalize or productionalize on this information and this insight. Another option we can consider is deriving predictive values. And this is a really wonderful feature in logistic regression. Once we're done with the analysis, we can actually enrich our existing data set by scoring every single visitor, every single observation in the data set with the predicted value that this regression analysis produced. Simply by clicking on this button, Visual Statistics will ask us to either accept the default naming convention or provide unique names for these two new attributes. I'm going to go with the defaults. And once I click OK, you will notice that here and towards the bottom of my list, two new attributes have been added to the dataset. Now there's one last feature I'd like to highlight before ending this demonstration, and it comes in the context of model comparison. So let's exemplify that we built this logistic regression, and now we want to compare it, say, with a decision tree analysis or other modeling analysis we've done in Visual Statistics, and we want to understand which modeling algorithm does the best job of fitting the data and the marketing question that we're addressing. So I'm going to come to the top of my menu, and I'm going to select Model Comparison. Visual Statistics will open up a window that will allow me to select each model that I've built, and I'm going to select a tree and the regression for this example, and I'm going to ask Visual Statistics to compare the two. And what I want Visual Statistics to inform me of is which model is better at fitting the same data. In this case, it very quickly tells me that based on the two models that I built, that the tree is doing better. Now, for those of you that are comfortable in data mining, you'll notice there are a number of different fit statistics that we can do this comparison on. We can also adjust our prediction cutoff, and by doing so, we may actually get different results. Again, we also have access to assessment plots that will showcase not just one model, but both models in that assessment view so that we compare and contrast visually. Now that we understand which modeling technique is a more accurate fit of the data, I'd like to conclude by summarizing what we've seen in this demo. We started by fitting a logistic regression to clickstream data and identifying drivers of conversion behavior from visitors. We then showcased capabilities in further optimizing the model by using group by functionality, which allowed us to build 7 different regression models based on the visitor traffic channel that he or she attributed from. Lastly, we showcase capabilities in comparing regression modeling with other modeling techniques to understand which actual algorithm is most accurate in fitting the data that we're researching. So that was the demonstration of Visual Statistics for predictive marketing applications using logistic regression analysis. We greatly appreciate your time today. We hope you enjoyed it.